Welcome to New Ideas to Mitigate Mining Liabilities and Capitalize on Long-Term Asset Opportunities webinar. I am John Lee, a senior civil engineer at BAR, and I'll be your host for today's webinar. Thank you for joining us. Today's webinar will provide valuable insights to help you proactively manage your mining liabilities and in some areas make assets out of what you may have traditionally considered liabilities. BAR has assisted national and international mining and minerals processing clients with complex, large-scale projects for more than 60 years. We offer assistance with everything along the mining development life cycle. By integrating engineering and environmental expertise, we can provide a streamlined approach to your project, one that improves efficiency, communication, and understanding of both the small details and the big picture. Before we begin today's webinar presentations, here are some logistics. First, if you're having trouble with Teams, please send an email directly to Lisa, Lungar, at bar.com, who is our administrative support for today. Second, the chat function in Teams is disabled. Instead, there's a link to a form to submit technical questions or discussion topics on the fly. I'd encourage all of you to submit questions during my colleagues' presentations. We'll accumulate these and address them in the final 15 minutes of today's presentation. You should already be viewing the presentation slides, which will be sent out at the end of the presentation along with a recording of the webinar. Finally, our contact information will be posted on the last slide today. Please feel free to reach out directly to any one of us. Now, before we begin on our three topic areas, let's have a brief safety share. As the new year has begun, we may be getting out more and taking personal or business trips by car. We all know that operating a motor vehicle is one of the most dangerous activities we undertake. If you plan to take a road trip, make sure your car is prepared. Gas tank is full, fuel levels are adequate, especially windshield cleaning fluid, and tires are properly inflated. Make sure you have an emergency kit in case you find yourself stranded by inclement weather. Make sure others know when you expect to arrive. Safe travels, everyone. Now to today's topics. We've seen several trends impacting our clients and their projects that are likely no surprise to you. The topics we'll cover today are a few trends of many. We're working in a dynamic environment and expectations are changing every day. We chose to address these topics today as they are what our clients have been asking us about most. First, the goal lines keep moving. New environmental standards are being developed frequently and established standards continue to change. This brings uncertainty and increased cost to closure, increasing long-term liabilities, and lends a sense of uncertainty around adequacy of designs. Second, the importance of social license to operate is becoming ever more important. Without social license, the ability to meaningfully engage with stakeholders is degraded, which can have a number of negative impacts. Third, commodity demand changes can change the timeline for mine closure. The increase in renewable demand is resulting in corresponding increases in demand for lithium, copper, and cobalt. On the other side of the coin, reduced demand for carbon-based fuels has impacted coal and oil sands markets. To cover these topics further, we've broken up the rest of our time into three different parts, presented by three of my BAR colleagues. First, you will hear from Ward Swanson, BAR's president and CEO and a senior chemist. Ward will speak to addressing liabilities related to emerging contaminants. Ward, who began serving as BAR's president and CEO in 2021, is a nationally recognized expert on environmental analysis, hydrocarbon fingerprinting, low-level mercury analysis, dioxin and furan analysis, and chemicals of concern such as PFAS and 1,4-dioxane. Next, you will hear from Todd Fasking, a BAR vice president and a senior environmental consultant. Todd will discuss how minelands, once considered liabilities, can be viewed as assets. Todd started with BAR in 1993. He leads BAR's permitting and compliance practice, and his primary focus is on multimedia challenges his mining clients face across the Americas. Third, Dale Kolstad, a BAR vice president and a senior environmental engineer, will speak. Dale will present the case for progressive closure. Dale has 2 decades of experience with projects involving civil and environmental engineering. He currently leads multidisciplinary teams in solving challenging mine waste and tailings projects across multiple geographies and regulatory jurisdictions. He has assisted clients in the development of closure and reclamation plans from early concept through detailed design. In our final segment, after the three presentations, I will return to moderate responses by the presenters to the questions and comments you share through the chat function throughout the webinar. So next, I will turn things over to Ward.
I'll be talking today about addressing liabilities related to mining operations, specifically environmental liabilities. This is something that we need to think about as we're in every part of the mine life, from developing to operating and closing a mine. And when we think about environmental liabilities in mining, there's been a long history of the moving goalposts. We'll say, water quality standards have gotten lower. Additional compounds have been added over time, started looking for things like dust, and even greenhouse gases are now something we need to be aware of. What I'm going to talk a little bit more today about, though, is something that's a little less obvious, those emerging contaminants. And specifically, this section is going to be focused on per and polyfluoroalkyl substances, or PFAS. We'll discuss why you need to care about this, where it might be found on your site, and what is the current regulatory pressures, and what can you do about it. So when you think about the question, why should we care about PFAS on our mining site, the answer is pretty simple. It's likely that you have it. Most industrial facilities have used chemicals containing these chemicals over time. And it's an up-and-coming environmental factor when we think about that ever-moving goal line of social license and environmental liability. As part of that moving goal line, it's also going to play a role in those ESG plans and social license reports. So cutting to the chase, as a mine site, where would you get PFAS from? And for most mining, AFFF is the primary source, aqueous film forming foam. It's a really good firefighting foam that's used in a lot of different areas, particularly the fuels industry, in the military, at airports, but also in the mining industry. These are called Class B foams, and all AFFF foams contain PFAS. The legacy foams contain PFOA and PFOS, which are the most regulated of those compounds. They're 8-chain fluorocarbons, and they were reformulated about 10 to 15 years ago to the fluorotelmer mix. And most recently, they've been reformulated again into using shorter chain compounds, more the 4 and 6-chain compounds. All of these compounds now have regulatory numbers associated with them. Another potential area where you see PFAS on your property would be from some historical flotation electrowinning chemicals. We don't see that as much, but that is a possibility if you use fluorocarbons in those areas, and also general maintenance things. As I said, most industrial facilities use these things in greases, hydraulic fluids, etc. For the mining industry, a secondary source would be biosolids and other beneficial reuse materials, which you may have imported to your property from public wastewater treatment systems or paper mills to help revegetate stockpiles. Most likely they have a PFAS source associated with them as well. So to back up, what are PFAS? Well, first of all, these are all man-made chemicals. They did not come from any natural clearing source, and they don't occur in any of your formations at your properties. They're heat, oil, stain, and water resistant. They have very beneficial properties that have been used in a lot of commercial products and residential products. They are resistant to biodegradation, which is good for those products, but not so good for environmental contaminants. They can be destroyed at high temperatures. They are semi-volatile, which means they can be put into the air with a heated process. And they're miscible in water, so like a lot of environmental contaminants, it's really easy to get it into the groundwater and really hard to get it out. And they do have some affinity for organic carbon, so they will bind lightly with organic carbon. So if you're thinking about biosolids and where the potential source of PFAS comes from, it's in a lot of residential chemicals used in the home, ends up in the sewer. The sewer treatment systems do not remove PFAS, so most of it passes through the system to the discharge, but some of it will attach due to that affinity to organic carbon to the biosolids. And if the biosolids are imported to your property, you will have a signature of PFAS associated with that. So why should you care about this? These compounds have been linked to multiple maladies, including some cancers, thyroid disease, preeclampsia, and ulcerative colitis at parts per trillion levels. And for those of you used to working in the environmental area, parts per million or parts per billion are typically the levels we look for. This is parts per trillion, so even an order of magnitude lower than that. Currently, they're beginning to be regulated across North America and all other parts of the world. The Canadian federal government has requirements for drinking water. They're their max standard. They have soil and environmental use standards. British Columbia has more stringent standards than the Canadian federal regulations. In the United States, it varies by state in the United States currently, as there hasn't been a lot of federal action until recently. All of those regulations are still in the parts per trillion levels. The U.S. federal government has adopted a new PFAS action plan, and they're moving to list 4 of these compounds, including 2 of the primary ones in firefighting foam, as hazardous constituents under the RCRA rules. And they're also moving forward with a nationwide maximum contaminant level or drinking water treatment standard. Another issue about why you should care about these things is the social license issues associated with them. There's been a lot of press about these. There's been a lot of action by environmental groups and local agencies related to these compounds showing up in the drinking water. The Flint water crisis really raised awareness about what people have in their drinking water, and PFAS has been another thing that has been adopted by these groups. There are environmental groups doing sampling around industrial facilities and writing their own reports and putting them out there in the press. And a lot of agencies in the states have began their own sampling plans of different industries. Mining industry is on some of these lists to be sampled, but isn't necessarily a priority as of yet. And the sensitivity does vary by jurisdiction. You'll find a very different reaction to these things in the southwest of the U.S., for instance, than you'll find in the Northeast, but all of them could impact your social license to operate and expand your operations. So what can you do about it? I'd start with an assessment. Start with the question, could you have it? Have you used these compounds? Where would they potentially be located? What are your sensitive receptors? Where would it be going? Which way does your groundwater flow? Is it going towards a lake, a stream, or a drinking water source? And don't forget about your own drinking water source at your mine site. And how would your stakeholders react? What's your relationship with the community you work with, the regulators you work with? What do you think their reaction would be if these compounds showed up in a downstream from your property? And then it gets into the debate. You need to make a decision of, do you collect data or not collect data? Some industries have decided to wait until the regulatory community comes to and samples their wastewater plants to figure out if they have a problem, and others have taken a more proactive approach. Some feel it's better to know than not know, but once you start collecting data, you should have a plan so you know what to do if you have detections and at what levels. The other thing we advise people is to get a regulatory and remediation strategy. Some potential actions you could do are source control. Do you really need to have AFFF at your sites? Could the fire potential at your property be less and you could go with a fluorine-free alternative? Also, excavation where it's been discharged on the property is an option, although it's getting more difficult to dispose of PFAS-containing soils. But there are some in situ remedies and some removal remedies, encapsulation, etc. But ultimately, it's a water treatment problem, and we usually walk people through a decision tree of things you have to decide. Will you run it through your existing water treatment plant with some modifications? Will you treat it in a localized area to remove the hot spots? Or would you treat the drinking water itself and hope that natural attenuation over time will dilute it out below any regulatory or detection standards? Those are all questions to answer. And as far as your regulatory interaction, this is new for the regulatory agencies as well. They're still learning as they go. It's been beneficial to set boundaries. What types of compounds are you going to look for, to what levels, prior to doing any sampling or remediation activities. There's new compounds being added to lists across the United States anyway, continuously. So having those set in stone ahead of time is very helpful. And when you collect data, do that with those goals in mind. Be deliberate when you're collecting it, both on who does the collection. It's good to have some experienced samplers, simply because cross-contamination is a real problem, but also do these data collection activities match your goals. So some key takeaways for PFAS are PFAS has emerged as a regulated contaminant and be present in many common chemicals. With growing regulatory and media attention, PFAS will continue to impact internal and external factors of your business operations. Second, identify and evaluate, assess your property. Everything from where it might be present, was it used, what your stakeholder perceptions would be, and is there a risk of migration? and what are your treatment options. And lastly, set a clear remediation goal, decide and develop a plan that fits you so you can address these things before they become bigger issues. With that, I will hand it off to Todd Fasking.
Thanks, Ward. Let's now talk about how we can turn potential liabilities of minelands into assets, or at a minimum, how can we reduce these liabilities? So what do we typically think of as assets at a mine? Traditionally, we think of the ore, the reserves, both proven and unproven. Think of the capital, the equipment, the buildings, the infrastructure, the staff at the facility, and on the negative side of the balance sheet, we think of the liabilities. Let's think of some other ways to get value out of these minelands. I'll talk about current developments that provide some opportunities to realize value outside of these traditional lines of thinking. So change equals risk and opportunity, and the expectations around social license to operate and environmental, social, and governance programs are rapidly changing. The worldwide mix of commodity demand and associated prices continues to fluctuate, and the ability to get permit approvals and associated stakeholder approvals isn't getting any easier. Extraction and recovery technologies continue to improve, and closure bonding requirements continue to be reevaluated. All of these changes overlap and intersect and provide opportunities to get additional value out of existing minelands. The concept is to leverage adjacencies and synergies to get this value, and could include things such as proactively engaging on social license issues to help with stakeholder engagement, identifying new revenue streams, perhaps mining unrecovered materials at permitted facilities with new technologies, or generating new revenue streams with renewable power, and also optimizing closure outcomes, perhaps incorporating the previous two concepts to minimize bonding requirements around land use. Example of doing something like this would be to use a previously disturbed landscape for a new useful revenue generating purpose, something like renewable power generation or storage, also called bright fields, that minimizes reclamation costs, but also supports ESG performance as expected by stakeholders. We will discuss some more examples like this in subsequent slides. So social license to operate is manifesting itself in several ways, including via ESG programs. ESG in the past has been driven by various stakeholders, but more recently there's been a lot of attention being paid to ESG programs by the finance community. This is because their stock owners and shareholders are asking for it, but also it's viewed as a mechanism to address some risk associated with environmental, social, and governance related issues. Mines can use a developed ESG goal or program to help frame how to manage minelands and realize benefits over the status quo. And design of an ESG program can also help identify ways to address some of the increasing regulatory pressures as the goal line continues to be moved. Another advantage, a well-implemented ESG program can minimize reclamation bonding costs by finding ways to reduce longer-term liabilities, usually related to environmental issues. Speedily getting to market is always desirable. Proactive ESG programs can help facilitate this by addressing stakeholder concerns. Some positive outcomes of this include mine development life cycle can be shortened. You can reduce the effort to permit the facility in time and cost, minimize your litigation risk, but nothing's free, so the trade-off may be an increase in capital expense up front to realize some of your ESG objectives. The example shown in the picture is a well-known copper project that failed to get approval in Alaska. One of the contributing causes for it not getting approved was lack of stakeholder support, resulting in social license to operate not being granted. This ultimately culminated with the project not getting regulatory approvals to move forward. So in addition to helping with stakeholder outreach, a proactive ESG program can help on the financing side too. The right ESG program can make the project more attractive, and this can result in a larger pool of interested financiers, And that can result in better terms, either from a cost or an ownership stake perspective. As mentioned before, there is pressure on the financier community from stakeholders to account for ESG and sustainability considerations. So if you have a program in place already, you should leverage it to help in this regard. If you don't, consider developing or putting an ESG program in place. Consider the varying indices, because there are a number, and which is going to be right for your situation. Just for your information, as of January 2021, 74% of those who report on sustainability use the Global Reporting Initiative standards for that purpose. We're now going to transition to potential new assets as influenced by social license. Realistic beneficial reuse provides the opportunity to repurpose mineland holdings or infrastructure for non-mining uses. Minelands can be repurposed for recreational, agricultural, and renewable applications, including power generation and storage. Any end use of minelands should consider stakeholder concerns. And there may be an investment to realize this end state, but reclamation cost requirements are typically incurred already, so the opportunity exists to leverage this investment to optimize the outcome. As we all know, siting new mines is capital and time intensive. New technologies and changing markets, combined with the existing established social license and equipment and infrastructure associated with existing facilities, make these facilities worth reevaluating to see if the resources that were previously deemed economically viable or unviable are now viable. This picture shown is of a project being undertaken where new grinding technology is making it technically and financially feasible to recover previously discarded iron units. In addition to the economic return on saleable product, the reduction in volume and composition of the wastes will reduce liabilities with the existing wastes. We're seeing other examples of this being applied in historic gold districts. We're also seeing examples where clients are evaluating recovering new commodities such as rare earth elements from existing waste streams. Mine impacted water can also be a resource, not just a burden for long-term treatment. As water supplies are scarcer and more stressed, water becomes more valuable. Base needs for environmental flows can be augmented by treated sources. The picture shown is an example of a pit lake being treated with alum with the goal of reestablishing biological systems to full function for use as an undiminished resource. Underground mines with stored cold reservoirs can be a natural resource for non-contact cooling applications. These same resources may be a good option to use for pumped storage applications, converting renewable energy to potential energy for later use. Irrigation needs can also be addressed via treated mine water. Siting renewables on mine lands is a natural application. The power infrastructure is typically in place and can be repurposed. The large land holdings are conducive to siting renewables or storage as well. In addition to pumped storage, water can also be used to power microturbines. All these applications improve social license, potentially reducing long-term liability and providing revenue opportunities. Reclamation strategies can be used to minimize bonding requirements and can potentially favorably impact reserve requirements and the associated timing. Turning the mineland into a productive use can help in several ways. First, you can change the status of a facility from care and maintenance to productive use, and you can avoid the need to demolish facilities. Productive use could expand the timelines required for closure activities, and if any, and can put off the timeline for spending on closures. Finally, you can turn abandoned minelands into productive use with low intensity development, potentially generating revenue. All of the above can build relationships and positively impact social license as well. Let me share two examples of putting underutilized minelands to productive use. The first is an example of a post-life of mine land use being creative with the opportunity that the mine setting provided. A new purpose-built mountain bike trail opened near Minnesota Discovery Center in Chisholm, Minnesota, in the iron mining district of northern Minnesota, is shown here. The trail traverses 1,200 acres of mining impacted land, including red earth surfaces, steep rock ledges, green forests, and open mine pits full of clear blue water. The Iron Range Resources and Rehabilitation Board supported the project with mineland reclamation and regional trails grants, all of which supports Minnesota's bicycling industry, which is estimated at greater than $700 million per year. Second example is where an old underground coal mine works was experiencing subsidence. The client wanted to use the surface more productively. The geotechnical and stability requirements for some solar array setups are much more forgiving to surface movement than windmills. We worked with the client to evaluate subsidence relative to the solar operational requirements and developed a workable solution to install the solar array on the previously unused surface. Now the previously unused land is generating electricity and revenue for the client. An electrical infrastructure that was a liability requiring demolition is now put to use. Let's turn it over to my colleague Dale Kolstad. He will speak to the concept of progressive closure and share more about how we can proactively plan for things like the two examples I just spoke to.
Thanks, Todd. I will be speaking to the case of progressive closure, or otherwise referred to as concurrent or integrated closure. If you haven't thought about progressive mine closure, now is the time, because your stakeholders are. And in today's modern mining world, we all know it's a lot better to be at the front of the pack than at the back. There are varying definitions of progressive closure, and mine closure requirements differ by regulatory jurisdiction and socioeconomic setting. For our conversation, progressive closure is the realized vision of how we will leave the mine site after productive mine life comes to an end. Conceptually, progressive closure provides an array of varying outcomes, along with a set of challenges and opportunities for the mine owner and operator to navigate. There are a lot of demands and expectations to sort through, from those inherent with acquiring and maintaining a social license, expectations for environmental stewardship, and moving goal lines within a rapidly evolving ESG framework. To better understand and make a case for progressive closure, I'm going to review the typical closure process and what that might look like, talk about some opportunities and challenges related to progressive closure, and share two examples of progressive closure in action. And lastly, discuss how closure planning aligns with the mine planning process. As we move through these topics, it will be clear that the use of the progressive closure approach provides the mine owner and operator with more control around how you engage stakeholders and respond to changing regulations, more control in spending throughout the mine life, and ultimately more control in providing an asset rather than managing a liability. First, let's take a step back and look at the typical closure process as illustrated here, where we begin closure planning and design during permitting and begin implementation of that plan as mine operations wind down. There is the greatest certainty at the end of mine life in this traditional sense, but the least number of options available. We can find ourselves stuck with disposition of materials, general topography, and hydrology. This often leads to significant monitoring, maintenance, and management in the closure and post-closure stages. The risk of water treatment into perpetuity remains a real issue at many mine sites in post-closure care. Finally, relinquishment is often extended well into the future, leading to long-term management of a legacy property. Here's an example of the typical closure process. This mine had the most certainty at the end of mine life, but the least options available. Operating for about a century, the new owner acquired an asset they had limited control over. A substantive waste rock pile had been placed over former fine tailing cells, which was convenient at the time, but led to significant physical instabilities. Our client was stuck with a massive pile and very little footprint with which to work. We optimized the landform design to the extent possible, but requirements for buttressing, slope flattening, and flood zone setback led to massive movement of material at a substantive cost, and the structure remains vulnerable to surface erosion, especially when factoring the effects of climate change. Our client certainly could not do all the things they would like to have done due to the substantive constraints imposed at this late stage of life. Compared to the typical process, here's the process re-envisioned from the end using a design for closure and closure first framework. We start by working from a post-closure vision that is shaped by the business case and license to operate, with defined future land use goals. This process also requires early engagement with invested stakeholders such as regulators, affected communities, indigenous peoples, and others. When approaching this topic, some people use the term end land use, but we prefer future as it reflects a new beginning. This re-envision process isn't a blue sky exercise, but it is a bit unbridled. Creativity is encouraged, and physical and economic practicality will ground the plan. Instead of a predisposed closure and reclamation stage, you'll see closure and re-blank. That's where creativity comes in. It can be reclamation with intent to restore or rehabilitate, or for future remining, repurposing, or other renewing ventures. A defined set of closure options are then generated and vetted for conformance with the mine plan. This helps identify real constraints and provides a basis for selection of the preferred closure option. Implementation strategies can then be considered within the context of mine development and operational tactics, providing means for control of disposition of materials, land shaping, and surface water routing toward the future use. And resourcing and funding can be better balanced with the ebbs and flows of operational demands. This re-envision process is also supported by the International Council of Mining and Metals Integrated Mine Closure Good Practice Guide, which encourages a similar process and provides a good framework for this type of closure planning. Now that we've reviewed what typical closure and re-envision closure processes might look like, let's discuss some of the challenges to mitigate and opportunities to capitalize on when considering progressive reclamation. Most of the challenges relate to dealing with the unknown and uncertainty of how the mine plan will evolve and risking significant material rework or creation of landforms that have integration issues despite efforts to circumvent it. The what-if scenarios can be daunting. We're helping a lot of clients identify and implement waste stabilization techniques, both geotechnically and geochemically, to mitigate those long-term liabilities that are the greatest cause of deferred closure costs. Most of the opportunities leverage the benefit of time and access to overburden materials, waste, and others that may not be available later. In this case, time and access act as the key to our theme of control. We've heard several clients tell us, I wish we had thought of this X years ago, and we could have done something different about it. That's becoming more prevalent with the integration of passive treatment technologies into the closure landscape. These are just a few of the trends we are seeing in the mining industry as they relate to closure planning and implementation. More thoughtful conceptual closure plans considering future land use scenarios, recognizing constraints based on the setting. Accessible environmental controls that are strategically placed, such as slurry walls, collector drains, and in situ treatment regimes. Use of waste materials for building materials and landforming. This includes the transition from traditional wet tailings and dams to drier, stackable material. Consolidated waste footprints going vertical where possible, providing larger buffer with sensitive boundaries and space to adaptively manage change. Strategic capping and covering, including timely placement to reduce exposure, but trade-off with waste settlement rates and early use of freshwater recovery. Resiliency assessment for climate change, where more extremes are happening every day. This is especially relevant for surface hydrology, but also for ecological development. And if you had planned for frozen ground conditions to mitigate environmental risk, that may now be off the table as warming continues. Our first example of progressive closure approach in action is for a mining client in the permitting and design stage of their mine. The inclusion of the closure plan at this stage and content of the closure plan is largely dictated by the requirements of the local rules. But our client viewed the plan development as a true opportunity to establish a closure vision upon which they could guide mine plan design and operational strategies. The plan is based on a vision of providing natural ecosystems consistent with the surrounding area. It considers a future land use composed of wetlands and uplands mimicking current features and natural analogs of the area. The design includes layering of controls for environmental protection following the primacy principles of avoidance, minimization or reduction, restoration or rehabilitation, and offsetting. Several mine features include progressive closure implementation during operations. For example, one mine pit will be progressively backfilled with waste rock from another to create a foundation for wetland development. This reduces the overall mine impacted footprint, will serve to maintain geochemical stability of the waste rock, and will replace lost wetland habitat. Landforming of stockpiles will resemble nearby rolling hills, and watershed development will restore natural flow patterns where needed and route main impacted water through constructed wetlands for long-term passive treatment. Through implementation of progressive closure, the passive treatment technology will be piloted early on, allowing for site-specific modification as may be necessary to meet water quality and natural restoration goals. Our second example is a recent progressive closure assessment we did for a client during the operational stage of their mine, as their first of many fine tailing cells was nearing capacity. Providing physical stability was a major driver for the closure concept, and the client wanted to know what landforms were possible, from an internally drained dish shape to externally shedding dome, or a hybrid of the two as is shown here. The use of the waste as a building material was attractive to raise the ultimate height of the feature, while still providing some top area for future freshwater recovery. Progressively raising the facility with smaller dike raises that could be used as an integrated cover was also attractive and could be aligned with the borrow source availability. When to do it is now the focus of discussion. With a long life of mine at this facility, there's a great opportunity to target the best timing for sequencing and to advance in an innovative cover design while de-risking the challenges of working with fine tailings. We are also looking at longer-term stability and incorporation of geomorphic evolution into the design, as well as natural analogs to inform the final closure geometry in future use scenarios. A sense of control was established for our client, and a more defined vision of success was created, which has provided a great platform upon which to advance their closure planning process. With a clear vision and opportunities and challenges identified, we can think about how closure planning fits into mine planning. Realistically, every mine is different and operates differently, just as every business does. We are hearing more and doing more progressive closure planning in parallel with the mine planning process, because as the mine plan changes, and the changes will occur, so does the closure plan. This might again sound daunting, but closure planning updates often do not require the level of rigor or detail that goes into mine plan updates. Rather, it can dovetail nicely. For the long range, the more comprehensive and integrated closure plan, or the playbook, if you will, is best created early and then updated every 5 years or so, especially for several decade-long life of mines. For the mid-range, more detailed components of the plan can be touched every year, focusing on the next year's reclamation work and any changes or learnings that influence the basis of design or presented opportunities or constraints such as excess or shortage of materials. For the short range, this is really fit for purpose planning. Some reclamation work will be completed like a project outside of the mine operations, and some as part of routine operations. In the past hour, we have touched on the topics that help you proactively manage your mining liabilities, and in some areas, make assets out of what you may have traditionally considered liabilities. We heard Ward share about addressing environmental liabilities, specifically focusing on PFAS, its growing regulatory presence, and how it will continue to impact internal and external factors of your business operations. Todd then shared the importance of viewing mine lands as assets, how the available assets go beyond the traditional viewpoint of ore and capital to include social license, beneficial reuse, and others. And you heard from me, sharing how progressive closure can be its own agent of liability reduction and aid in long-term asset creation that works in tandem with mine planning. No matter where an owner or operator is in their mine life cycle, there are opportunities to apply these topics in useful ways, not only to meet, but to exceed modern expectation of miners. I'm going to turn it back to John for our Q&A.
Well, thank you, presenters. This is John Lee back again. We will go over some of the questions that we've received over the course of the presentations. I would encourage you, if you still have questions, we can look at those as if some additional questions occur to you as we're answering some of the questions we've already received. I'm going to start with one question that I'll address, and then I'll ask Todd perhaps to elaborate on it. But one of the questions is what are we seeing as trends in risk assessment in the industry? And I'm not sure whether that question was really targeted at traditional risk assessment that might be driven by certain regulatory requirements. But I will say that all of our presenters today talked about the idea that risk and risk management and understanding the risks beyond regulatory risks, there are financial risks, there are reputation risks. That's really what we're focusing on in all of these talks today. So I hope you get that takeaway that the idea of risk management in the mining industry is evolving, and it's not just, there's a lot of different stakeholders, and it gets to that social license issue that Todd and Dale and even Ward talked of. But I'll ask Todd if you'd like to elaborate on that topic.
Sure. Thanks, John. Yeah, we've seen risk show up in a number of different ways, and I think Dale talked about some of them. Some of the physical risks associated with climate robustness. So we're seeing it on the engineering side, and we're also seeing it on the trying to de-risk. And it talked about a little bit in the ESG piece as well. What things are out there relative to permitting risk or long-term legacy risk, which is also something that Ward talked about as well. So I think the main thing is to be aware of those risks and then plan up front, as opposed to trying to catch up on the backside. So that seems to be what it's kind of a big bucket, but folks are a lot more proactive as far as thinking just about not just about what's the risk relative to a 100-year flood or something like that. It's the risk is larger than that, and that's I think the biggest thing we've seen change in the last few years. I'd throw it over to Ward or Dale if they want to pile on top of that. Otherwise, back to John.
All right, thanks, Todd. Another question that came in was about a specific state, but I'll broaden this question for Ward, and it gets back to the PFAS topic, is what are we seeing as particular states or other jurisdictions, regulatory agencies asking and requiring sampling and work around PFAS? Could you elaborate a little bit more on that, Ward?
Sure. Yeah, the general approach that has been taken in most states has been to start where they most suspected. So the industries they target are typically the airports, landfills, and wastewater treatment plants. And then from the wastewater plants, they've been looking for going upstream of that and finding out who the major contributors are and where they can minimize that. I think some states like California have named specific industries, including the mining industry. Other states are proceeding on the basis of permitting. So in Minnesota in particular, that's their approach. So it does vary, but I think in the states where they're targeting particular permits, I think they're using their judgment on who would be the bigger users of these chemicals and the potential large contributors. The other sampling that's going on is the typical UCMR, which is a national drinking water effort where they sample drinking water systems that serve over 3,300 people and then a subset of smaller ones. And they have expanded the PFAS list to 29 different ones on that, which also could, then from there, they would start looking for what those sources are.
All right, thanks, Ward. Next question I'll direct to Dale, and others may want to chime in after Dale answers it. But there was a couple questions around BAR's experience with remediation, with tailings contamination and particular contaminants, and how maybe you could elaborate a little bit more on how our processes work around that.
Okay, yeah, thanks, John. And I plugged in my earphones because I was having a little trouble with my audio, so hopefully we're okay there. Yeah, that's a good one and a pertinent one. A lot of our clients are asking what can they do with their tailings. As kind of a reoccurring theme was the physical and chemical stability of tailings. It's largely the most significant mine waste product that our clients need to deal with, and so with that provides a potential real opportunity for kind of that reprocessing and recovery element we talked about and Todd mentioned earlier, with some of our rare earth metals and that sort of thing. So there's certainly potential there, depending on the deposition history. Obviously, older tailings are a little bit more usually ripe than more recently deposited tailings with the improvement in recovery and that sort of thing. So it depends on where it is, how you can get to it, but then yeah, on the what can you do with it after the fact. So certainly they're usually hand in hand in terms of if you can recover more from them, you can make them a little bit more inert and more stable for a constructible type or building material at the mine site. So there's some attraction there. I think on which contaminants, I think the sulfur, the ARD metal leaching scenario is a common one. It's obviously a very significant challenge, and every site is different, but and kind of in the toolbox, you got the encapsulation, you have passivation, you got oxygen control. So it's really kind of fitting the right remedial technique to the setting.
All right, thanks, Dale. Maybe you can elaborate on that a little bit, Todd, but let me throw another question at you. Maybe you can talk about both of them a little bit. You talked about ESG and social license. What are some of the, I guess, low-hanging fruit, or the kind of some of the first steps that mining organizations might take to address some of the ESG pressures they're seeing and concern about social license?
Thanks, John. Kind of key to all of that is kind of understanding your stakeholders, both your internal stakeholders, your external stakeholders, what's important to them, and figuring out how you can make that work within your business as well. And it's good business, obviously, to have your stakeholders engaged and satisfied, as I touched upon in my discussion. It helps in a number of ways. A couple of things. It depends on the setting as to what the stakeholder concerns might be. Independent of that, just about every place you go, there's a lot of talk about either greenhouse gases or energy efficiency or something like that. So that's something that folks are looking at and thinking about. And how can you most efficiently do this when you're upfront doing your design, be it your fuel mix, be it your process mix, be it efficiency in operations, be it your energy supply. Another large component that we talked about was water, and how you upfront, water scarcity in some locations, or water abundance, and what are you going to do with all that additional water? Sometimes it can potentially be a benefit, and how can you figure out and capitalize on that, especially when your stakeholder community is interested in what to do with that water.
Okay, thanks, Todd. This one I'll direct at Dale, but Todd may want to have some follow-up because it touches both on the closure, progressive closure perhaps, and some of the ESG things. But one of the questions we got was, there seems to be a lot of interest in renewables, particularly solar, repurposed on mining facilities. There's technical challenges. There's also maybe issues with the bonding for the reclamation. What do you see as the future of renewables on mining sites, and where are the opportunities there? What are the challenges?
Actually, I'll let Todd maybe take a first cut at that one,
okay,
since he was talking about that in more detail.
Thanks, Dale. There's a lot of interest on it. We're seeing some programs in different regulatory bodies encouraging that. You have to make sure it's a right fit with. You got to have your connection with the grid. You got to have a user, and you got to have the right foundational conditions, as well as the right I don't know. Are you going to put solar in a place that doesn't get much sun? Are you going to put a wind farm in a place that doesn't have much wind? Are you going to put some sort of micro turbine in a place that doesn't have a lot of potential energy in the form of a drop? So your situation is going to depend, but it's also we're working with developers to come up with how is that not only is it going to help feed the facility's energy needs, but then if you're looking to get it back into the grid, how is that going to work? You got to take that into consideration. And typically a lot of the mines have a lot of energy demand, so they're already plugged into the grid in some form or fashion. So I don't know, Dale, if you want to, anything else you want to add to that?
No, I think you got it pretty well, and I think that's the interesting scenario is because as the mine's winding down, and you said when you're going into closure and reclamation, you don't necessarily need a lot of power, and especially if you're kind of moving more towards a passive treatment regime for any residual contaminants and that sort of stuff rather than active treatment, the power demand goes way down.
So as Todd mentioned, it depends on what's going on next door. I think a lot of that's an important aspect too. Is there other mining development next door or any other developments that there's a power need for, and it can be pretty competitive on the pricing. But from the repurpose, so that's from the economic side, but from making some value out of your mine land too, it certainly can be a good way to use for the actual land use in the future too. I mean, you might be in a situation where, a natural restoration or an agricultural restoration, things like that aren't as attractive, whereas putting out a large solar field could be very attractive because the mine site's already cleared. It's got, a nice open window for that exposure. So it could be very attractive depending on the setting.
I think another thing I would add is, as you guys mentioned, infrastructure is a real big deal. If you need to build a high voltage transmission line to connect to export your power, that's a problem. But the flip side is most of the mining facilities have had good infrastructure because they've been using a lot of electricity, so they can use the substation that was bringing power into the facilities to get it out. So there's that. But as Todd said, it's very competitive. And so even what we think we have got a lot of good solutions for foundation, enhancements but if there are other sites that don't have any need for any special foundation needs, that could put you out of the running. So it's a very complicated process, but we certainly are seeing both from developers, utilities, and from mining companies a lot of interest in this. I think we will see more and more. Okay, thank you. One question, and this may be, we'll probably have time for a couple more, but Dale, maybe you could talk a little bit more about how progressive closure can help with how that impacts bonding and financial commitments necessary. What are the advantages and the challenges around that?
Yeah, besides a lot, yeah, in terms of cash flow and trying to maximize profit on a year-on-year basis. I think, starting holistically, it's important from a corporate perspective when we talked about ESG, and this certainly fits in that category, is how you're managing those liabilities in the long term and what you're creating in the future, and how your communities and stakeholders view that. So that's a significant driver that affects how you want to manage your funds. But I think on a practical basis, there are opportunities. I think every mining client I've worked with, there's some opportunity in the mine plan when materials are moving around to capitalize on doing some of the progressive closure pieces. It ends up being like a large puzzle, figuring out which pieces to manipulate when. But there are cost advantage ways to handle materials during mine operations that can get you that progressive closure scenario. And I think with regard to financial assurance and bonding, the sooner you can release some of those obligations, typically the better. A lot of them, I get everything's, site specific and permit specific, but a lot of them are tied to having a stabilized site, right? In terms of having your vegetation growing. And so, getting part of your footprint established and getting vegetation on it just reduces that line item percentage. So you start to move some of those off the ledger, and that's less money that you have to hold out into bonding. So I think there's some real attraction there, and it also is kind of the side one is it protects you. Some of the clients I'm working with that are progressively closing some of their facilities, they just don't have that exposure vulnerability with some of their mine rock stockpiles and that sort of thing, where large climatic event comes and they aren't exposed like they would have been if the whole pile was open.
Okay, maybe one good one to close with is maybe all or any of you could answer this question and elaborate a little bit more. I know many of you touched on this, but how have mining operations changed? We talked a lot about closure and what you can do at the end to as part of reclamation, but what about the mining process itself? What things have happened or do you see happening to reduce carbon footprint of mining operations? You've touched on some of those, but could you maybe give some other examples perhaps of what we've seen organizations are doing? And
So
I guess maybe the one thing, I'll answer my own question, maybe just real quickly, because one issue that I think many of you are aware of is electrification. And, you know, we did one study in Minnesota for engineering, or for a utility and the mining company, on how we could look at electrification of their mining haul trucks. And that's an example. There's a lot of things in operations. And so I think in general, electrification is one issue of how to do that, assuming then that the electric source has a lower carbon footprint. But that's one specific example where I think you know, that are, you know, real things that could happen in the near term. But I don't know, did any of you have any other examples?
Yeah, I was gonna pile on to that, John. That obviously that's one component for sure. If you even go back a little bit further upstream, thinking about efficiencies in operations, not only is that good for the environment, that's good for the bottom line. So it's a win-win. So upfront or even retroactively, I mean, some of the stuff, the low-hanging fruit, that's, you know, variable speed drives and stuff like that. That those things have been pretty well pursued and implemented, but those basic concepts, how can you have an efficient process up front, and then you go into the fuel mix idea, and as one part of that being the electrification. And then when you're talking about electrification, like you said, not only is it electrification on site, but then figuring out, as you alluded to, John, what your supplier's, you know, footprint is when you're thinking about the indirect emissions, when you're looking at evaluation of your greenhouse gas footprint. So those are kind of the bigger things right now.
Okay. Well, we are at our appointed ending time, so I do want to honor people's time, but I want to thank everyone for participating. I want to thank our presenters. You did a great job, and thank you for those that submitted questions and for your attention. We will be, as we mentioned earlier, providing you copies of these presentations, and if there are some questions that are maybe more specific that we didn't get to, we'll try to respond to you individually on some of those questions you may have. So again, thank you, everyone, and have a good day.